Continuing on in section 2.10, we can use percents to compare estimated or measured values to actual or exact values. So the take note on page 146 talks about relative error. Relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual value compared to the actual value. When relative error is expressed as a percent, it's called percent error. So that sounds like a lot of words, guys, but we're still going to do it the same way that we did percent change. We're going to find our change, okay, bigger minus smaller, then divide by the actual here. So instead of dividing by original, we divide by the actual, which is kind of the original if you think about it, because the actual value of something, it really is what it is before we guesstimate it, okay? So the actual is the original. A decorator estimates that a rectangular rug is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet. What is the percent error in the estimated area? So here we're comparing areas. We're going to find our percent error in the estimated areas. So let's figure out what our areas are. Our estimated area, she estimates that it's 5 by 8, which gives me 40 square feet. The actual is 4 by 8. Which is 32 square feet. So to find our percent error here, we find our change. Divided by our actual, which again is like our original. This rug was originally 4 feet by 8 feet before the decorator decided that maybe it was 5 by 8. So the actual is our original as well. Our change then, I always want to take bigger minus smaller, so 40 minus 32. And our actual is 32. Here, I can subtract 8 over 32, which simplifies to 0.25. We want this as a percent error, so I move it 2 places to put my percent sign there. So 25% error. Feel free to pause here and give this a try. You think that the distance between your house and your friend's house is 5.5 miles. The actual distance is 4.75 miles. What is the percent error in your estimation? So here we're looking for percent error, and it's in the distances, okay? We're talking about distance, so we don't have to calculate anything else here. My actual distance is 4.75. And my estimated, what we think, is 5.5. So to find our percent error, we take our change divided by actual. Here, that change is going to be 5.5 minus 4.75, bigger minus smaller. And we divide by actual, which is here. It's actually 4.75 miles. According to PEMDAS, we have to do our subtraction first. We divide, and I get 0.15789. Okay. We want to write this as a percent, so I'm going to move it 2 places and round it. 8 rounds up. So it's about 15.8% error. Or you could have rounded it to 16. Often we don't know the actual measurements exactly, but we know how precise our measurements can be. The most any measurement can be off is by 1/2 of the unit used in measuring. So when you say how tall you are, for example, you might say that you're 5'8". since you measured to the nearest inch there, you might be half an inch shorter, you might be half an inch taller, but you rounded it down to that 5/8. And we can use that same idea here all the time. So you're framing a poster and measure the length of the poster to be 18.5 inches to the nearest half inch. What are the minimum and maximum possible lengths of the poster? So we start off with 18.5 inches. That's what we rounded it to. And we measured to the nearest half inch. So that half inch, okay, is what we're going to use to figure out how far away we could be. We're going to take that and divide it by 2, and we get 1/4 inch. So I could have had 1/4 inch this way and 1/4 inch that way, and it would have rounded to that 18.5 inches. So for example, if I take away 1/4 here, and it's 18.25, if I was only measuring to the nearest half inch, that 18.25, I'd round it up. If I add that 1/4 on, I get 18.75. Okay, if I'm measuring to the nearest half inch, okay, that would have been the point in which I switched from going down to above. So it's the part where it splits into our rounding. Okay, 18.25 is where we start rounding to 18.5, and 18.75 is where we stop rounding to 18.5. And that's because of this nearest half inch. So it's like a half inch on both sides. If we add them up, this total is a half inch. Okay, anything below that rounds down to just 18. Anything above that rounds up to 19. So again, we take whatever we're measuring to, half it, and we add it and subtract it. So the minimum possible is the 18.25. The maximum possible is 18.75. Anything more than that, we'd round up to 19. Anything less than the 18.25, we'd round down to 18. Now, a student's height is measured as 66 inches to the nearest inch. What are the student's minimum and maximum possible heights? Go ahead and pause here and give this a try. So we start off with 66 inches. And we're measuring to the nearest inch. So I take that inch, 1 inch, and I half it. So we could have actually had half an inch smaller or half an inch bigger. Those are our cutoffs. Anything more than that, and we round it somewhere else. So here, 66 minus a half is 65.5 inches. 66 plus a half gives me 66.5 inches, and those are my cutoffs. Again, anything less than 65.5, we'd round it down to just 65. Anything more than 66.5, we'd round up to 67 inches. So because we're measuring to the nearest inch, we are trying to figure out those borders. Okay, at what point does it split to be above or below? So the lowest it could have been here, our minimum, is 65.5. Anything less than that, and it would have rounded down further instead of going up to 66. Our maximum is 66.5. Anything less than that, it goes to 66, but anything more, okay, would go up to 67. The diagram on page 147 shows the dimensions of a gift box to the nearest inch. Here it's 6 inches by 12 inches by 5 inches. What is the greatest possible percent error in calculating the volume of the gift box? So a couple things to note here. We are talking about volume of the gift box. We're finding percent error. It was measured to the nearest inch. So we're going to find both our maximum and minimum values for each one of our dimensions, find our area or our volumes, and then compare to find our percent error. So if we're measuring to the nearest 1 inch, the furthest they could be away from that is half an inch. So our dimensions are 6 inches, 12 inches, and 5 inches, our length, width, and height. Now, if we could be ½ inch away, we could be ½ inch below, or we could be ½ inch above. And all of those measurements would have rounded to 6, 12, and 5. Anything less than that goes down, anything more than that goes up. So it would have been either 5 or 7, 11 or 13. Okay, so my minimum measurements here are 5.5, 11.5, and 4.5. My maximum measurements are 6.5, 12.5, and 5.5. Now, to find the volume, we take length times width times height. Length times width times height. And we do that with our measured amounts here as well. My measured amount is 360 cubic inches. On the maximum, I'm going to get 446.875. And on my minimum, when I multiply the 5.5 times the 11.5 times the 4.5, I get 284.625 cubic inches for each of those. So those are my volumes, my minimum volume, my actual volume that was measured, and my maximum volume. We're going to treat that measured volume like the actual since that's what we're comparing it to. So now, in order to find my percent error, I need to find my change or my difference between them. So I'm going to subtract between these two, 360 minus the 284, and I get 75.375 cubic inches difference. Between my maximum and my measured, when I subtract here, I get 86.875 cubic inches. Now, to find the greatest percent error, we take the greatest difference. So I'm going to use between my maximum and my measured. We take that and we divide it by our measured, which here we're treating like our actual because that's what we're comparing it to. When I divide there, I get approximately 0.241. We want this as a percent error, so I move it 2 places, and it's about 24.1%. That 1 rounds down. So about 24% error is our greatest possible error. And again, that's because the greater the difference, the greater the error. So we picked the bigger of the two differences, divided by what we were comparing it to there, that measured amount, and got our percent error. Quick recap here. When the original amount and how much it's changed is known, a percent change can be found. And relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual value compared to the actual value. And that's all I have for section 210.